Okay, so again, the discussion for today is a review in chapter 7. I will just uh, add more inputs on the chapter and just basically talking about um, comparative statics and partial differentiation as well. So when we talk about comparative statics, we are allowing to change in parameters or endogenous variables and how or exogenous variables and how it affects the equilibrium values. And we're doing that. You know, we're allowing to change allow a change in any of those parameters by using partial derivatives. So as you know, when we talk about partial derivatives, class, it means you have a function, and it means that you have y is a function of independent variables x sub 1, x sub 2, and x sub n, and how a change in one of those independent variables would directly affect a change in y, or would have a change in y, and holding other things, or while holding other independent variables constant. So again, comparative statics again uses partial differentiation just to know how the new equilibrium position will compare with the old. Now, our examples last time as well was on marginal utilities and also on the marginal product of labor and capital. Today, we'll go back to our discussion in chapter 3, which is equilibrium analysis. And we'll talk about, again, a change in any of those parameters and how it affects, say, a change in P star and a change in Q star. Okay. So going back to chapter 3, equilibrium analysis, we have a basic supply and demand model. We have our demand function there, which is QD is equal to A minus BP. Just again, a review of what those parameters meant. A there is our intercept, and A there is our intercept, and we have B as our slope. So again, when we have A there, it means simply that that is the price that, or that is the level of consumption that consumers would consume or would buy if the price is equal to 0. And we have our negative P, which is again our slope. That means that for every 1 unit increase in P, Q falls by B units. Okay. We also have our supply function, which is again assumed to be linear. So we have our QS equal to negative C plus DP. Negative C is again our intercept. That is the quantity that producers would sell if the price is equal to 0. So it is just understandable, class, that if the price is set equal to 0, because prices are seen to be a signal for producers to produce more, and if it is equal to 0, you'd know that suppliers would be hesitant. And so again, it is just acceptable to have a negative intercept. We also have our D there, which is our slope for the supply function. That just means that for every increase, or for every 1 unit increase in P, Q rises by by D units. Okay, so we also had assumed that all the parameters A, B, C, and D are greater than 0, therefore positive. Now we will have to look for again our endogenous variables, which are P star and Q star, and then we can do that by again by equating this supply and demand functions. So we have our equilibrium condition. For chapter 3, what we did was again we solved P star and Q star using substitution elimination method. We can also do that using matrix algebra, but in this case, we can just go ahead, and since we're familiar anyway with how we solve using elimination and substitution, we can just do so, and that's how we got that's how we got P star. So P star there is equal to A plus C is equal A plus C over B plus D. So again, all your endogenous variables there are expressed in parameters. By solving P star, we also can get Q star. So from Q star, we just substitute it to any of those functions, demand and supply functions. In this case, I chose the demand function and we substituted it. So again, we simplified as well this part here. And that's how we arrive with Q star, which is equal to AD minus BC plus AD minus BC over B plus D. Okay. So again, we're just revisiting of what we have learned in chapter 3. And why is it more relevant today in our discussion in chapter 8 and 7? That is, what will happen, class, if if we allow a change in any of those parameters? Say, for example, a change in A, change in B, and a change in C or D. Now, again, we're using partial derivatives here. So in that case, we will have four partial derivatives. We have partial P, partial A. We also have partial P, partial B. We also have partial B, we have partial C, and we have partial B and partial D. But anyway, in this case, we are getting the partial derivative with respect to all of these, respect to each of these parameters. Okay. Now, the first thing in this case, class, let's try to look this one by a parameter, the changes in this parameter. I only prepared 3 changes in this parameters. You can do the rest. You can also do a change in Q star. So as you can see here, we're starting first with what will happen with the when we allow a change and how it affect the how will that affect equilibrium price. You can also do the same later on equilibrium quantity. Okay, so for now, equilibrium price muna. Okay, so in this case, class, what is the partial derivative? So question mark here states is that would that yield a negative sign or a positive sign? So if it is greater than 0, again, let me just write this one. So if our partial derivative, okay, here is greater than 0, or that means that it is positive, it means, class, that an increase in A, let's just say an increase in A, would also increase and would yield an increase in P. So that means that if the sign is positive, it means that P and A move in the same direction. Okay. However, if this is lesser than 0, which means to say that this is negative, this would mean to say that if there is an increase in A, there would be a decrease in P. So they have, you can now see that they are moving in the opposite direction. Okay, so how will we know? If the sign of the partial derivative? So we can only know here the direction. It's quite tricky to know also the magnitude. So we'll just concern now on the direction of the parameters. Okay, so let's start first with getting the sign. Okay, getting the sign of A here. Okay, or the partial derivative with respect to A. Okay, so right, let's start first with this one here. Okay, we started off with our equilibrium values. So for P, so that's P star is equal to A plus C over B plus D. Again, we can treat this one as, or we can treat our parameters as variables. Therefore, we have a P star now is a function of the variables A, B, C, and D. So again, we're now treating this one as variables because we're allowing one variable to change and holding the other things, all the other variables constant, or the other B, C, and D as constant or fixed. Okay, so again, we're also using, to get the partial derivative with respect to A, we are using quotient rule here. Okay, so again, I just wrote this one. I just wrote the quotient rule on the side, just a guide. But again, you can that is already inherent to you, so you can might not write it down. So you know that. When you proceed to this one, you get partial P, partial A here. You get again the first order partial derivative with respect to A, holding the other parameters constant, P, C, and D. Thus, you get 1 over B plus D. Okay. So again, you just use the quotient rule here, and you have your partial derivative, which is equal to 1 over B plus D. Okay, so I hope there's no I hope this one is clear. Again, what we did here is just we're getting a partial derivative. We're using the quotient rule. Now, how would we know again the signs? We go back to the assumptions that we have made with our models. Okay, so when we go back here, class, we know that the assumption is that, or the standard assumption is that all are positive. So A is positive, B, C, and D, they're all positives. Now, assumptions are always critical in a set, in especially in economic analysis, because that is again how you would allow the signs in partial derivative. So when you go back to that one, which one is that? Here. So you know that B is positive, D is positive, again, given by the assumption that we made earlier. So you can just write it this way. So B is positive, then again, positive sign, and you have D is positive as well, and you have a positive numerator. So in this case, class, your numerator is positive, your denominator is positive, so your overall, your total sign is a positive. Okay, and so in that case, when you go back to this one, you know that, uh, you just change this one. Oh, okay. You know that when, you know that if this is positive, this would be greater than 0, and they will move on the same direction. So if there's a change in A brought by an increase in that parameter or in that variable, it will also move direction. So this would be a P star now. Okay. So again, right. So an increase in A would bring an increase in would increase in the equilibrium price itself. Okay. So okay. Now, after that class, it's always helpful to also graph it, because again, it allows you to not only see what happens, but also gives you a good analysis. So to graph that one does, it would look something like this. So again, A was our intercept in the demand function. So it means that because the total effect was a positive, the partial derivative is also is positive. So it means to say that in the graph, now when we start off with the point A, so point A is at P1 star, and then it means that if there is an increase in A, there would also be an increase in B. Now let's look at the graph class. Okay, if let's see if it is the same with what we said, what we mentioned earlier. So at point A, it's in P1 star, and also here. Okay. So in that case, A here is again, we had a parallel shift of the demand curve. And so in that case, class, what happens is that there was a decrease rather of A here. So we will just change our direction here. And so there was a parallel shift to the right, and yeah, to the left. Okay, so there was a parallel shift to the left, indicating there was a decrease. So in the entire demand function. So in that case, there is a decrease in A. That means that P star should also decrease, which is also the same in the graph there, because there was a movement from point A to point B, indicating that there was a decrease also in price. So in that case, class, just also so in that case, there was a decrease in P, and there's also a decrease in A. Okay, but the standard way to do it is always to first look at the parameters. So let me just correct. That is a change in a decrease in A would mean a decrease in P. So let me just I can see. Okay, here. That's what happens anyway. This is supposed to be treated. Right. So again, this our graph confirms that a decrease in A would bring a decrease in the equilibrium price. Okay. Now, before I proceed to the next one, do we have a question, class, on specifically for a change in the parameter A? Okay, so just basically, this is just again another application of the partial derivatives. So it is again equally important that you know how to do partial derivatives in the same time, also how to check the signs, and I also encourage you to also do graphical analysis. Again, it really does cements your understanding. Okay, so since there's no question for this one, we'll head to the next one. Okay, now yeah, let's go back to this. So we're done with a change in the parameter A. Let's also look at the change in parameter B. Okay, so again, I've prepared until C. You can do D later. Okay, so for B class, again, we still don't know yet on whether they move on to the same direction. So later on, we'll also do the same exercise. So in that case, it's still a question mark. Is possible that a change on this parameter would be a positive or a negative one. But for now, we actually don't know yet. So we'll do the same exercise. Let's just go to that. So in that case, yeah. So you can see here, we are still treating B as one of the independent variables. So B star is again a function of A, B, C, and D. And we're still using the quotient rule here to get the first order partial derivatives or to get the partial derivative with respect to B here. So again, just we had this exercise this morning, so that's why we were quite limited with time. And so in this case, I hope you can still follow. So what we did here again, quotient rule. So that's f prime g minus f g prime over gx squared. And again, it resulted to a zero. So 0 times b plus d, that's a 0. So that's minus a plus c multiplied by 1. So in this case, class, it's obvious that we arrive with a negative numerator. So that's negative a plus c over b plus d squared. So again, this is positive. B is positive, D is positive, your denominator is positive. Okay, let's do also this one similar to this. Okay, for a while, let me just put it just to be consistent. Okay, so A is positive. Okay, so we have a negative sign. We also have positive A because again, going back to our assumptions, so that's positive, and we also have positive. Okay, and then B is positive. Okay, so the overall sign here was is okay. All right. Putting that one on the side. So again, we are guided here with our assumptions that we made earlier. So B and D are positive, all the parameters are positive, but then again, your numerator here is a negative. So that means that the total effect is a negative. Okay, so when you go back again, when you go back to this one here, you know that if there is in here, let me just go ahead here that let's just say there is an increase in A here, then there will be a decrease in your P. Okay, so again, the total effect or the a change in the parameter P yields or affect the equilibrium value by a decrease in P here. Okay, so again, the next thing to do is to look at that one in a graph. So we just go back to my old file, which is again this one. So what happens here is that we started at point A. So at point A, we have P1 star, and then there was also, yeah, and then after there was a change in the parameter B. Okay. Okay. So what happens here is that the demand curves becomes steeper. So again, it is consistent with the idea that we mentioned earlier that P star and B moves in the different directions. So when in there, if there is an increase in B, there would be an the equilibrium price would fall. So technically, class, again, if B gets smaller, B gets bigger, and vice versa. So okay, so the idea really is just they move in different directions here. Okay, so right. Okay, so again, as you can see, we have three things to do here. We first get the first order partial derivatives, we check the signs, and then afterwards, we get the graph, or and then after that also interpret. Okay. Now, so that constitutes just again, the graphs class are very specific to the change and the parameter. So in this case for B, there was very specific on that there was an increase in parameter B. But again, you can use this one class. This is again a more general sense on the change and a change in the parameter B. So what will happen? You know that if there's change in a parameter B, it's always in opposite direction for B. Okay, so the same as this one as well. Obviously, there was a decrease in A here. So the graph is very specific to a decrease in A. But again, this is the entire thing here is that it helped you with the move, with the direction of the equilibrium value in question. Okay, so now let's do the same exercise for C. Although we actually in my earlier class hindi kami nakaabot ng C, but I think for this class because we have more time, let's do C. We can do this one as an exercise. So we'll go back to this one. Let me just go back to this one here. We start. Okay, let's use this one. Okay, so I'll stop the recording. No, I'll pause the recording. Okay, so wait. In this class today, we have noted that there was let me just go over. Okay, so in this case, so now you can see. All right. So again, with the same exercise, just like we did with parameter A and B, we also did the same for parameter C. And then again, using the same quotient rule, we resulted that we got the result that partial P partial C is also a greater than 0, which means P and C move in the same direction. So this one again move in the same direction. Okay, this one. An increase in C would also have an increase in P. Again, they move in the same direction. Also for D, which is where is D there? So now yung D. Okay, here. And also we did the same for D. So again, we get partial P, partial D. And using the same quotient rule, we noted that it has it is lesser than 0, which means it moves D and P star would move in the different directions. So just to complete this is just to complete this one class. Again, just to complete this one, this is again partial P partial again partial P partial P and B. This one is greater than 0, they would be same direction. And this one as well is lesser than 0. Okay, so very specific again when we go back to this model right here. Okay, so when we go back to the model right here class, okay, this was we started with this demand and supply function. We also noted that these are the assumptions in the model. We know that any of the changes in these parameters would have this effect to the equilibrium values P star and Q star. Okay, now our exercise again for today was only on P star. We will also do the same exercise again in your free time on the values for let me put this one on the side. on Q star as well. Okay, so again, on free time, you can do the same exercise now already for Q star. Okay, so let me just go ahead. Q. So in this, again, on your free time, again, you can do the same exercise for Q star. What will happen in that equilibrium value when any of this parameter would change? And as you can see with this model alone, you would have to get at most 8 partial derivatives for that. Okay, so let's try one more. Let's try one more for Q star A class. No, let's do Q star. Let's do this one here, partial Q, partial P, again, just to compare siguro our answers. Since this was our exercise last earlier in my class. So let me just show that one already. Okay, so ito. Okay. So we did the same exercise with my other class, and again, we know we did for Q star. Now, in this case, we had our equilibrium quantity, which is equal to AD minus BC over P plus D. And then after, we treated this one again as Q star as a function of A, B, C, and D. And we use the same quotient rule to get the partial derivative, which is again equal, which is lesser than 0. Okay, so in this case, we've also compared class. We've also compared this one here. So, okay, so in that case, this one is what we did earlier. In this case, again, the same exercise. We noted that they move in the different direction. Okay, so a decrease, or let's just say an increase in B would equate or would be equal to a decrease in Q here. Okay, now just to be careful of your analysis later on. We know from the law of demand that this P and QD would have a negative relationship, would have an inverse relationship. But as you can see here, they also do have an inverse relationship. Okay, so you might want to also add to your exercise later on, again, a graphical analysis showing also Q star. Okay, now questions class on again how to arrive with the values here. None. All right. Okay. So, okay. Now let's proceed to the second one. I think I just need to leave you with an exercise on or a model for all the indigenous variables. So example 2 is a comparative static analysis now in the macroeconomics national income model. So again, we have here the national income model with that. No, let's use see, I'll just use a basic one. Okay, so I'll just delete this one. Okay, let's use this time. This is already macroeconomics national income. Right. So we start off with our model. Again, you can we are just looking back with our models in chapter 3. So we have y here, which is again equal to c plus I plus o. So let's have that one as a 0 subscript. So let's also have our consumption function, which is again, this is equal to sub-0. And we also have c here, which is equal to a plus by. Okay. All right. So for our example for macroeconomic national income model, we have these two models. We have y is equal to c plus I plus g. Again, and we also have our c here, our planned consumption expenditure, which is equal to a plus by. So again, starting off first with defining our parameters and our variables. Um, our indigenous variables here, again, what we're looking for is again our y star and c star. We also have our exogenous variables, those variables that are determined outside the model. We have our investment and we have our government spending. We have I or G here. Now, let's also classify our parameters. Hmm. Let's have our restrictions class. I'll use, okay. I'll put the restrictions on the side. Again, this will guide us later on with our science. So, uh, A here would be greater than 0. Okay, so A would be greater than 0. Okay. Again, I think you already know this one, that A and B are, again, our marginal propensity to consume. And so our restriction would be A would be greater than 0. It would be positive. And B, let's try to restrict our B here to 0 less than B. That is 0. Okay. All right. So this would be our restrictions class on the side. A would be a greater than 0, and B is restricted in 0, which is 0 less than B, greater than 0 less than 1. Okay. Okay. Now let's try to solve this one first. Let's try to solve this one first. Put this one on the side, just a guide. Okay. So perhaps in the exam you'll do the same exercise. Okay. So again, all right, let's substitute this one to this. Okay. And then simplify, put the y on the side. So it's by a plus I. And this is again the same exercise, just like what we did with chapter 3, but now we're allowing other parameters to change. Simplify, so that's y minus 1 minus p equal to a. Okay, and we isolate p here, isolate y rather, so that would be 1 minus p. So 1 minus p. Is it correct? Okay. All right, here. Okay, so again, we've only solved so far our equilibrium y star here, or y star. So again, it's equal to a plus I plus g over 1 minus p. Now, doing the same exercise for partial derivatives, we will need to solve for partial y, partial a. So let me just write it down. Y star. Let's have partial here. So partial y, partial a. Also do e here. And IO. Okay, so please bear with me. And also, G. Okay. Okay, so I am just completing class what partial derivatives we need to look for in this model. So we have 4 partial derivatives. Again, very specific first muna. So y star, you can do the same exercise for c star later, but for now we'll just only have y star. Okay, so we have y star, we have partial y, partial a, and also with respect to the parameters b, investment, and government spending. I think I will probably just do 2 class, and you'll do and you can do investment and government spending later on. Okay, so what would be, how will we do this? We can first get this one. Again, I am solving for we are solving for partial y, partial a. Okay, so that's for okay, so partial y, partial a. Okay, see. Okay, here. Okay, so from the equilibrium value, from the one we solve, we'll get the partial derivative with respect to a here. So how do we again solve this? Okay. This is again, this is one, this is, can you use the quotient rule again? So that would mean that this now will become, uh, okay. So we'll not write anymore the quotient rule class on the side. I'll go directly to uh, performing it. So that's 1 minus b, 1 minus b, and then we have, okay. So, hmm. Okay. See. And okay. Okay, here. Right? Is it correct? Oh, okay, we can still simplify this one. Right. If this is 1 minus b, 1 minus b squared. Okay. For a while. All right. Incorrect. Okay, here. Okay. All right. So again, we started, we used the same processes just like we did with basic supply and demand model. And then we get the partial y, partial a, simplified, and we end up with 1 minus b, 1 over 1 minus b. We go back to the restriction just to check on the signs. So we have a numerator positive, 1 minus. So b, there a restriction for b is less than 0, greater than 0, less than 1. So it would be positive, positive, positive. So okay, the the sign as a whole, or the sign for this partial derivative, would be greater than 0. Okay, so just to add to our economic analysis for this one, a here is again our autonomous consumption. So that is the intercept of the plant consumption expenditure. So in that case, class, it means that, let's just, because it is positive, we know that they would move in the same direction. So in that case, if there is an increase in A, it would also affect the equilibrium value Y star, also on same direction. So in that case, an increase in A would also increase Y. So how much consumption will Y have if there is an increase in A? Okay, so again, A there, in theory, is our autonomous consumption. Okay, so all right. Now, great. Uh, hmm, okay. A question about this model. Okay. Now, we're now left with, again, we can answer A and B. You can do the rest for investment and government spending. I'll just complete B for now. So doing the same exercise for B class again. Let's try it. We'll change this one to partial Y, partial B now. And again, I am still using the same equilibrium value for Y star. So let's try to get a partial differentiation to that. Do it, okay, sige. This one would be, this one would be, hmm. Okay, so just to complete comparative statics analysis for B here, again, we just use the same model and then we use the quotient rule. By the way, class, what you can see here that this is yeah, okay. So as you can see here, you can actually simplify this one because again this one is we cannot will not carry this one over because it is multiplied by 0. So negative times negative, you'll end up with a positive value for a plus investment plus government spending over 1 over b squared. Now you can also simplify this one further because a plus io plus go is equal to y star itself. So we can just simplify it and then you can come up with this answer, which is y star is equal to 1 minus b, 1 minus b. And so again, guided by this one here, we know that the values are positive. So again, you have a positive denominator. You also have a positive denominator. So that means that the whole effect is a positive. So what this tells us is that if there is an increase in, what this tells us is that there is an increase in B would also have an increase in Y here. Now, guys, because we're talking about macroeconomic variables here, you know that a change in your B class will have a huge effect on your Y star. You see, if you can, in policy, I mean, if you can manipulate this one, if you have, um, uh, if you manipulate B class, it will have a huge effect in Y star. Okay, so again, this one class tells us that if there is a small change in the marginal propensity to consume, again, it will have a huge effect on the national income. So if people again will start again, if people will start consuming, if people spend a lot on consumption, it will have a effect on Y. So um again, this is very relevant today, class, especially that if the economy is in again is contracting, that one way to have a huge effect on the on Y star, which is again the total output, is to let people spend. Okay. And so I think I just remembered an article on this one, class, in order to move forward with the economy, because again we have a negative 16.5 last year. The economy was so bad. What will happen is that try to increase spending, especially in household. So how do you do that? You cash aid, again, just to just just to allow people to start on spending. Okay, so again, that if people start spending, it will have an increase in the economy. Okay, so in that case, so I think we will end our discussion in this one here. So you can still extend, you can still solve in your own. I and G can also use solve on your own. C star as well, the partial derivatives for C star. Okay, so I think that will end the discussion, also end the recording.